All right, so I just want to review, make sure that you're clear on identifying weak acids, weak bases, strong bases. Just especially just being able to identify when you see an acid versus a base. You've already seen this before, so it's not new. And the reason that it matters whether it's strong or weak is because the strong things break apart completely in water. They do things like conduct electricity. They also end up with very strong pHs and pOHs, which is what we also will be talking about. Whereas the weak things, you can see there's some positive and negative, but they also just stay bound together and don't do anything. So they don't conduct electricity as well. But let's make sure we can identify acids first. So I'm zooming in right here. So an acid is something that has an H on the front side. So I've got some H's identified. So H, 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 H on the front side. That's going to be an acid. Then and there's other stuff that falls afterwards, and that's okay. If you look over here, there is the COOH, and we also talked about that one. That's a special kind of organic compound, but we will use it a lot this semester. You'll learn more about it in organic chemistry if you take it. But this one is kind of funny. The carbon will not give up that oxygen. The carbon just really has to have that bond with the oxygen. It will not give it up. So it looks like that it should be a losing OH group, but that carbon, there's no way. You're not going to break that CO bond. But the oxygen is kind of happy to lose that H. So this look is the other look of something that you're going to see as an acid. You also will kind of learn about something else. Water can act as an acid or a base. So we could also put water in this category of looking acidic. Notice it does have an H on the front. If you wrote it like this, you could see it having both the H and the OH group on it. But those are our acids. So look for that. H in the front, COOH, those are our acids. Now we're going to move on to looking at our bases. So the bases all have, for the strongs especially, OH, 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 OH. So those all have OHs, and the strong ones, just as a reminder, are the first column plus OH. And then this is actually the lower half of the second column plus OH. And they all have a +2 charge. That's why you need 2 OHs. So basically, if you have an OH, or over here, an OH, do you see FeOH? Another round of OH. If you have an OH in there, and it's kind of grouped like this, like we're not talking about like carbon bonded OH type things, but it's a group like that, and it's got like parentheses around it. It's like positive, negative type thing. That's going to be a base. And then here are some other, we talked about this is kind of a strange compound, but this is a special kind of a base right here. And it's special, you'll learn about us talking about Lewis bases, and it's special because it has that lone pair on it. So any kind of like, I call these carbony looking molecules, but like carbons and H's with all these lines in them. And then if you have a nitrogen stuck in there, and if it's only got 3 bonds, then the nitrogen has an assumed lone pair in there. You can also do nitrogens that have like 2 lone pairs. So as long as it has a lone pair on there, you're good to go. Note that when nitrogen has 4 bonds, let's see, those are all H's, he doesn't have the lone pair anymore to act as base. So this one is not going to be a base. But again, look for look for OHs and look for the nitrogen. And then another one, water can behave as both. And you could imagine that one because you could imagine the water being written as HOH. So it can behave as both. So you will also learn of some other cases of a few things that will behave as both later on. But I just wanted to be completely clear what we're looking for when we're looking for acids and bases. Then we're going to talk about why they're acids and bases and what they can do as acids and bases.